This is a recording on how to verify trig identity, and in this one we're going to be looking at this double angle. So secant of 2x is 1 plus tangent squared x divided by 1 minus tangent squared x. And in this one we'll probably work with the right side most, since that seems the most complicated. But I do want to change this secant of 2x just a little bit here. So we'll change that to 1 divided by, let me get the right pen, so just 1 divided by the cosine of 2x. So we know secant is 1 divided by cosine of 2x. The reason I'm doing that is that I have a double angle on the left. I don't have double angles on the right. I'm going to want to change it back. So since I don't off the top of my head know the formulas for the secant of a double angle, I'm going to change that to the cosine. And the cosine, we have a few options. You can use the cosine squared minus sine squared, or the 2 cosine squared minus 1, that sort of thing. So since I don't exactly know which one I want to use just yet, I'm going to leave that for now. But that's sort of the goal I'm shooting for on the right side. So let's go ahead and try to change this right side a little bit. So this 1 plus tangent squared x over 1 minus tangent squared x. We'll go ahead and change the tangents to sine and cosine. Let's see if that helps a little bit. So I'm going to write this as 1 plus the sine squared x over cosine squared x on the top. So just change that tangent to a tangent squared to a sine squared over cosine squared. Same thing on the bottom. I'm going to get a 1 minus sine squared x over cosine squared x. Then after that I have these complicated fractions inside of fractions, but at that point now I can actually reduce by multiplying the top and bottom of that larger fraction by a cosine squared x. So we'll just multiply the top and bottom there by a cosine squared x. Alright, at that point, now I'll go ahead and multiply that through, and it is important that you distribute that through that whole thing. So we're going to get the cosine squared x times the 1 and times the sine squared over cosine squared. And so that just distributes through. Same thing here, that cosine squared x, that's going to multiply by the 1 and the fraction as well. So if we go and do that, cosine squared x times 1, that's just cosine squared x. So cosine squared x plus, and then sine squared divided by cosine squared, that cosine squared x will cancel out with the other one, so we just get a sine squared left over right there. And then on the bottom we'll have same thing, cosine squared x times a 1, so we get cosine squared x. And then the cosine squared times sine squared over cosine squared. Cosine squareds will cancel out, and we'll just get a minus sine squared x at that point. At this point, now you have to go ahead and look at your identities for these sum and difference of squares. So cosine squared plus sine squared x, hopefully remember that is just 1 right there. And also this cosine squared x minus sine squared x, that is just this cosine of 2x. So that's one of our other identities for the double angle for cosine. So that is the cosine of 2x right there. So you kind of have to recognize some of these going backwards. So instead of changing the cosine of 2x, sometimes you'll go backwards and just recognize, oh, cosine squared x minus sine squared x, that is the cosine of 2 times that angle x. And then after that is pretty easy, so that matches with what we already have on the left, but a lot of times we'll just, if it's just one extra step, go ahead and write it. So this is the secant of 2x, which matches what we had on the left side, so at that point we're done.